everybody, welcome to another video. Hope you're ready to flex those brain muscles. We're gonna find the area of a sector. We're gonna learn how to find the area of any sector from a circle. So we're given some circle. This is a sector. It's basically a piece of the circle. It's kind of like a piece of pie, pizza, however you want to think of it. It's a piece. So we're finding the area of this piece. And the size of this piece, well, it depends on some central angle theta, very similarly to arc length, right? And we have this area formula, area of a sector. So arc length, we derived our formula using circumference. So what do you think we're going to do in this case? We're going to use area, because we know the formula for the area of a circle. Now we're trying to find the area of a sector. So it's going to be a similar process with how we derive this. Again, you could just memorize this, I guess, if you want, but I like to show where this comes from. So pi r squared, this is the area of a circle, but we don't want the full area, we want a piece of the area, and this piece depends on theta and how big theta is, okay? So we have this multiplied by theta over a total possible 2 pi radians, okay? Hopefully this makes sense. We have theta radians out of a total possible 2 pi radians. If we're doing a full rotation, then our theta is just 2 pi, and we have pi r squared times 1, which is correct, because that's just the area of a full circle, okay? If we have half a rotation, let's say we have our theta is pi, then we have 1/2 of the area of a circle. So hopefully this is making sense, and again, I can simplify this. The pi's will cancel, and I'll have r squared theta over 2, which is exactly what I have here, 1/2 r squared theta. In this case, the 1/2 is just pulled out in front, but it's the same thing. So if you ever forget this formula, just think about area of a circle and then multiplying by theta over 2 pi. So let's go ahead and get to a couple examples. We're going to solve for whatever unknown. Again, in this formula, very similar to arc length, we have 3 unknowns: area, radius, and theta. So we can be given any 2 of these, and we could solve for the third one, right? So in this case, I'm given a radius of 10 meters, a theta of 1/2 radians. Theta has to be in radians, has to. And we're asked to find the area. So I'm just going to plug in. So our area equals what? Let's see, 1/2 r squared, that's 10 squared. Theta, that's times 1/2. So I have what? 1/2 times 1/2, that's 1/4. 10 times 10, that's 100. 1/4 times 100, that's actually 25. Okay, quick maths. All right, now we're gonna find the area, but look, we have a small issue. We need this to be in radians. You can't just go plugging this in. This is the biggest mistake students make with these kind of problems. So I gotta convert. How do I convert? Do you remember? 30 times pi over 180. This is how I convert from degrees to radians. So 30 goes into 180. Let's see, what does this simplify to? 1/6. This gives me pi over 6. Does that make sense? I cross this out, I wrote a 6, cross this out, I wrote a 1. So pi over 6 is my angle in radians. So now I can just plug in for the area here. I have 1/2 5 squared, that's 25. And then I have what? Theta, pi over 6. All right, now I can do the algebra, work this out. Let's see. 25 over 2 times pi over 6. That is 25 pi over 12. Let me make sure this is right. Let's see. I squared that, multiplied by pi over 6. That looks correct to me. Let's see, 25 over, yep, cool. Oh, I forgot one thing. What did I forget? Meters, okay? Since my radius is given in meters, my area will be in meters as well. And you could even write meter squared if you want. Meter squared. I don't know how picky your instructor is with the units, but whatever units your radius is, that will be the same units as your area. And whatever units your area is will be the same radius, vice versa. The units of your angle theta, always radians. Always radians. If it's not radians, you have to convert. So I'll give one more example where we solve for the radius. All right, let's finish up the video with this example. We are given theta in radians, no converting needed. It's pretty nice. Area, 6 centimeters squared. We are asked to find the radius. So I have all the information I need to find the radius. I just need to make sure I set this up correctly. I have 6 equals 1/2. I'll put this in parentheses, times r squared times 1/4. Okay, so I have 6 equals what? Well, I combine this 1/2 and 1/4 into 1/8. So I'll draw an arrow. I have 6 equals 1/8 r squared. I need to isolate this r squared so I can take the square root of both sides, right? So I can multiply both sides by 8. 8 times 6 times 8, 48. Remember those times tables? 1/8 times 8, that's 1. That's why I multiplied by 8, because I knew that would be 1. R squared is what I'm left with on the right-hand side. Now what? Square root both sides. Remember what you do when you square root? Plus or minus. Plus or minus. So I have r equals plus or minus square root of 48. But wait a minute. Radius, that's a length, right? A length can't be negative. Let's throw that out, okay? Length can't be negative, so we throw that out. I just wanted to point that out because a lot of people will accidentally get the right answer. They'll forget that plus or minus is a thing, so they'll just take the principal square root and they'll, by chance, by luck, get the right answer, okay? But just always make sure. All right, so now I can do like a prime factorization. I can break this up, simplify it a little bit. This is the correct answer, but I'm gonna simplify this. I can break this up into what? Ooh, this breaks up nicely, actually. 16 times 3. Okay, square root of 16. Well, let me write out each step. So this I can break up into 16 times 3, and I can split these up using my square root properties. Square root of 16 times square root of 3, which equals 4 root 3. Oh, and I need to be careful. I am in centimeters, so I'll write centimeters here. So that is my radius. Hopefully this video helped. If it did, make sure to hit like, hit subscribe, check out my channel for more videos. Keep flexing those brain muscles. Leave any questions in the comments and keep making those brain gains. I'll see you in the next video.